Our next problem is a pretty interesting problem. In the first part, it is given that 1.22 grams of benzoic acid is added to two different solutions in two cases, and some data are being collected. In the first part, in 100 grams of solvent, for that solvent, Kb is 1.7 and the elevation of boiling point is given. And for the second solvent, the Kb is given and the elevation of boiling point is given. We need to find the molecular weight of benzoic acid in both the cases and need to comment on the results obtained. And in the second part of the problem, we are given that degree of ionization of a decinormal solution of barium chloride is 80% at 27 degrees Celsius, and we need to find the osmotic pressure. So let us first do the first part of the problem. We have delta Tb, that is the elevation of boiling point, to be equal to Kb into m. This m is the molality of the solution. For the first part, this is 0.17 is equal to 1.7 into molality, which is moles of solute. This is 1.22 divided by the molecular weight divided by the weight of solvent in kilograms, which is 100 by 1000. This makes the molecular weight first to be equal to 122 grams. For the second solvent, we have 0.13 is equal to 2.6 into 1.22 times m2, or rather divided by m2, whole divided by 1 by 10 again. This gives our m2 to be equal to 244 grams. Hence, for the first solvent, the benzoic acid weight is 122 grams, and for the second case, it is 244 grams. On seeing this, we can very clearly see that this is exactly double of the earlier molecular weight, and hence we can comment that in the second solvent, this benzoic acid is dimerizing to form a dimer, and hence the weight has doubled due to the formation of a dimer in the second solvent. This completes the first part of the problem. For the second part, we are given that the degree of ionization for a decinormal solution of barium chloride is 80% at 27 degrees Celsius, and we need to find the osmotic pressure. Now, barium chloride, being an electrolyte, dissociates in aqueous solution to give barium ions and chloride ion. If the initial number of moles of barium chloride is 1, this becomes 1 minus alpha, alpha and 2 alpha. Hence, the final number of moles become equal to 1 plus 2 alpha. Alpha is given to be 80% at 27 degrees Celsius. We'll put the value of alpha afterwards. The Vent-Hoff factor becomes 1 plus 2 alpha divided by 1, which is equal to total number of moles present after dissociation and total divided by the total number of moles before dissociation. This is equal to 1 plus 2 alpha, that is 1 plus 2 times 0.8. This is equal to 2.6. Now we know that the osmotic pressure is equal to Cr into T. This T is the temperature, this R is the universal gas constant, and C is the concentration. But here the electrolyte which we the solute which we have is an electrolyte. Hence, this concentration will get multiplied by I, which is the Vent-Hoff factor, and hence our formula for the osmotic pressure pi is equal to 2.6 into C, which is given to be a decinormal solution, which is n by 10. So this is 1 by 10 into R, which is equal to 0.0821, into the temperature, which is given to be equal to 27 degrees Celsius, that is 300 Kelvin. Hence this becomes equal to 6.4038 atmospheric pressure, and hence our two answers are: for the first part, the molecular weight of benzoic acid in the two cases of 122 grams and 244 grams. 244 grams was due to the formation of dimer, and in the second part, the osmotic pressure of barium chloride solution comes out to be equal to 6.4038 atmospheric pressures, and these are our final answers.